Welcome. I am the Body Whisperer, and I am glad you are here. Let us go quietly inside you to meet Melatonin Mila, one small part of you that keeps working through the night while you sleep. Deep inside the brain, the pineal gland waits for true darkness, and the moment it arrives, Melatonin Mila begins her quiet shift, sending the body's one essential message. The day is over, and sleep is allowed. But first, let us settle in together. Find a comfortable position. Let your arms grow heavy, your legs, your shoulders. Take a slow breath in, and let it go. One more. In and release. Good. Now, while you rest here doing nothing at all, something quiet is happening inside you. Your body is working. It always is, every hour of every day, without ever asking for thanks. I want you to get to know it a little better, to listen to it, to feel it, to appreciate it. Because the more you understand the quiet world beneath your skin, the more at home you feel inside your own body. There is nothing you need to do now. Nowhere to be, nothing to figure out. Just breathe. Close your eyes if you have not already, and let us begin. There is a quiet piece of work going on inside you right now, and it has been going on every night of your life. Deep inside the brain, not at the surface where thoughts race and memories sort themselves, but further in, near the very center, there sits a structure about the size of a pea. Smaller than a grape. Smaller, really, than most things you would bother to notice if you held one in your palm. It is called the pineal gland, and for most of human history, nobody quite knew what it was for. Philosophers guessed it was the seat of the soul. Anatomists measured it and moved on. It sat there, in the middle of everything, keeping its own counsel. Turns out it was just waiting for the dark. The pineal gland has one job, and that job is reading the light. Not seeing it exactly, the gland has no eyes of its own. It learns about the world outside from the eyes you do have, through a long and careful chain of signals that runs from the retina, through a small relay station in the brain, and finally arrives at the pineal gland like a message delivered by hand. When the light outside is bright, that message says, "Hold, when the light fades, when real darkness falls, the message changes." And the moment it does, a small figure inside the gland quietly begins her work. Her name is Mila, Melatonin Mila. She is not dramatic about it. She does not announce herself. She simply begins, the way a night shift worker arrives at the side door, clocks in without ceremony, and gets on with things. Mila is the body's darkness signal, melatonin, made and released by the pineal gland, and her one purpose is to carry a single piece of information to every cell that is listening. The information is this: the sun is down, the day is over, it is safe now to let go. That is the whole message. It is smaller than you might expect. And it matters more than almost anything. Here is the thing that most people have backward about melatonin. They hear the word and they picture a switch. Something that knocks you out, the way a heavy meal can make you slow, or the way a darkened room makes you squint. But Mila is not a switch. She does not force sleep on anyone. She is, if anything, closer to a permission slip. She rises through the bloodstream in the evening hours, reaching quietly into the body's systems one by one, and what she says to each of them is not sleep now. What she says is, you may sleep, it turns out, is downstream of that permission. The body already knows how to sleep. The pressure for it has been building since morning, accumulating the way a tide comes in, hour by hour, unhurried and certain. What Mila provides is the signal that the time is right. The door, when she arrives, was already there. She is the one who turns the handle. The pineal gland has been doing this for longer than anyone can measure. Long before electric light, long before glass windows, long before anyone sat in a room staring at a bright rectangle late into the evening. In those older arrangements, darkness arrived reliably, and Mila arrived with it, and the body drifted towards sleep along a schedule that had been set and kept for generations. The system was simple because it did not need to be complicated. Darkness meant night, night meant Mila, Mila meant rest was allowed. Something remarkable happens when the light truly goes. The pineal gland, which has been holding off all day, begins to release melatonin in a slow and steady rise. Not a flood, just enough. A long, quiet signal that spreads through the body like the last of an afternoon settling into evening, gradual, certain, unhurried. The body's temperature begins its own slow drift downward. The sense of wakefulness, which has been propped up all day by competing signals, begins to ease. Not because anything is being turned off, because something is being allowed to wind down. Mila knows this. She has always known it. The pineal gland, for all its smallness, is one of the oldest parts of the brain's inner machinery. Older, in evolutionary terms, than many of the structures built up around it. The information it carries has not changed. Darkness means the same thing now that it meant before there were words for it. And the signal Mila sends is the same signal that has always traveled this route, through the same pathways, to the same listening cells. So if you are lying here in the dark right now, and the room is genuinely dark, or close to it, then somewhere in the center of your brain, the pineal gland has already gotten the message. Mila is already at work. The signal is already moving, and the body you are resting in is already, quietly, in the process of letting the day go. You do not have to do anything. You do not have to try. The machinery is older than trying. It knows what darkness means, and it knows what to do with it. The breath is easy now. The weight of the body is real. And Mila, small and unhurried at her post deep inside the brain, is simply doing what she has always done, carrying the one message that night was always meant to deliver. The room is dark, and the dark is kind. Sleep is not something you reach for. It comes and finds you. There is something worth sitting with for a moment. The pineal gland has no windows of its own. That sounds like a problem. For a gland whose entire purpose is to know whether it is night or day, you might expect it to be positioned somewhere near the surface, near the skull, near the eyes, somewhere with a view. Instead, it sits at the very center of the brain, tucked between the two hemispheres, wrapped in the deepest tissue of the body's most protected organ. It cannot see the sky. It never could. And yet it knows. Here is how that works. Far forward in the head, behind the eyes themselves, sit two small clusters of nerve cells, a paired structure called the suprachiasmatic nucleus, though what matters about it is what it does rather than what it is called. Think of it as the brain's master clock. It receives a direct signal from the light-sensitive cells at the back of the eye. Not the cells that see shapes and color, different cells entirely, sitting quietly in the retina and doing one job only. Measuring the presence or absence of light, they count the light. They send the count forward. When that signal says bright, the master clock relays the message, hold off. The pineal gland waits. Mila waits with it. When the signal says dark, genuinely, consistently dark, the clock releases its hold. A quiet biochemical permission travels the short distance from the clock to the pineal gland, and the pineal gland begins its work. Mila steps forward. And what she carries is not a sedative, not a sleeping pill manufactured by the body. It is something quieter than that. It is a time stamp. That is worth saying again, in plain words. Melatonin is a time stamp. It tells the body not what to do, but when it is. Right now, the pineal gland is saying, it is night. The date and the hour confirmed by the oldest timekeeping system the body has. Everything that knows how to respond to night, and a great many things do, receives that confirmation and begins to shift accordingly. Mila knows this. The shift is not dramatic. It does not arrive with a gong. The body does not suddenly dim like a theater going dark. What happens is more like a tide going out, a gradual, even withdrawal of the day's urgency. Warmth redistributes toward the skin, which is one of the body's earliest signs that its internal clock has registered the evening. The core temperature begins a slow decline, not a steep drop, a drift. The kind of drift you would not notice if you were paying attention to anything else, but that the body's cells notice with great precision. And downstream of Mila's signal, other systems that have been holding their positions all day begin to ease. not because sleep is being manufactured somewhere. Sleep is not manufactured. But because the announcement has been made, and the systems that were keeping watch are receiving permission to stand down. Cortisol Carl has been part of this story all day, though he prefers not to think of himself as a character in someone else's story. His role is the morning, a reliable, purposeful surge that lifts alertness from sleep and hands the body to the waking world. He is good at his job. He does it every day before the eyes even open. But his rhythm, like Mila's, is tied to the light. And as the evening arrives and Mila's signal rises, Carl is supposed to be winding down. He does not love working late. He will say so in his own way, simply by making the body feel a low resistance to rest when his levels are where they belong, which is lower here in the dark. The two of them do not work in the same room, but they are part of the same clock, and when one is on schedule, the other usually is too. When Mila's signal is early and strong, Carl's departure is clean. The transition from day to night in the body's chemistry happens the way it was always meant to. Gradually, smoothly, without a seam. Mila knows this hour. The ancient quality of all of this is something easy to overlook. The pineal gland is one of the oldest endocrine structures in the vertebrate body. Glands that release their signals directly into the bloodstream, skipping the long relay of the nervous system. The relationship between the pineal gland, darkness, and melatonin appears across a span of animal life so wide that it is easier to note the exceptions than the rule. Fish have it, reptiles have it. Birds carry it, and many of them use melatonin's rise and fall to trigger migrations that span continents. The mechanism that Mila works within is not new. It was not invented for people lying in lit houses at the end of a long day. It was already running before there were houses, before there was any kind of shelter at all. All that has happened is that the same signal, the same chemistry, the same pineal gland is now doing its ancient work inside a species that has added electric light to the world. The system did not change. The context around it did. That is not a complaint. It is simply the shape of the situation, old biology, new surroundings, the same message being sent every evening regardless. Mila carries her time stamp into the dark with the same unhurried precision she has always had. It did not make the night easier to navigate. It made the night legible. Everything is quieter than it was a moment ago. Even the small sounds have gone soft around the edges. So the night has become legible. The body knows what time it is, not by the clock on the wall, but by a signal older than clocks, older than calendars, older than the idea of timekeeping itself. And now the question worth sitting with is this: what exactly does Melatonin Mila do with that information once she has it? Here is the thing people almost always get wrong. Melatonin is not a sleeping potion. It is not a sedative slipped into the bloodstream to tip the brain into unconsciousness. Mila does not work like that. She is not a switch. She is closer to a town crier, the one who walks the streets at dusk, ringing a small bell, not to make the townspeople fall down, but to let them know the working day has ended. What they do with that information is their own affair. She delivers the message, the rest follows. The message itself is remarkably simple. Darkness has come, the sun is down. The long argument of the day is over. That message travels through the body in the form of melatonin itself, a molecule small enough to cross into places most molecules cannot reach. The pineal gland, that quiet pea-sized structure folded into the center of the brain, releases it directly into the fluid that surrounds the brain and spinal cord, and from there it moves into the blood. It disperses widely, broadly, calmly. There is no targeted delivery, no single destination. The message goes everywhere at once, because the whole body needs to know. And the whole body does, in fact, respond. Body temperature is one of the first things to answer. Through the evening, as Mila's work begins in earnest, the core temperature of the body drifts downward, a small, slow, reliable drift. Not a dramatic drop, a settling. The kind you feel when a warm room gradually goes cool, almost without noticing it, until you realize at some point that you have pulled the covers a little higher. That is part of the same process. The body is making itself ready, and the cooling is part of the readiness. This matters more than it sounds. Sleep, particularly the deep, slow kind that comes early in the night, runs better in a cooler core. The body has known this for as long as bodies have been sleeping. Mila's signal does not cause the cooling directly. The relationship is more like a cue than a command. She announces the hour, and the hour carries its own biology with it. Mila knows this. There is something else worth understanding about how the signal works, and it is the part that makes melatonin genuinely unusual among the body's chemical messengers. Most signals in the body are responsive. They spike because something happened. They fall because something stopped. Melatonin does something different. It follows a rhythm that is built in advance. The timing of Mila's rise each evening is not improvised. It is anticipated. The body begins preparing for her arrival before she even shows up. The master clock, that small paired cluster of cells above the crossing of the optic nerves, the structure called the suprachiasmatic nucleus, keeps melatonins schedule the way a conductor keeps time. It knows, based on the day's accumulation of light signals, roughly when darkness is coming. And it begins the handoff early. The pineal gland does not wait to be surprised by nightfall. It is already leaning in that direction by the time the light fades. This is why the change at dusk feels gradual. It is gradual. Mila does not arrive all at once. She rises slowly, the way the tide comes in, not as a single wave, but as a long, patient, inevitable climbing of the water. By the time most people notice they are sleepy, Mila has already been at work for a while. The drowsiness is downstream of the signal, not simultaneous with it. There is a word for the time of evening when melatonin first begins to rise. Researchers call it the dim light melatonin onset, meaning the point in the evening when the gland begins releasing melatonin even before the room is fully dark, in low light, as a kind of early preparation. It is the leading edge of the tide, a sign that the system is moving even before the final conditions are fully met. What this means in plain terms is that the body is not waiting for complete darkness before it starts. It is reading the direction of the light. The slow dimming of late afternoon, the gold shifting to amber, the sky dropping its blue, all of that is information. The pineal gland, reading that information through the long relay from the retina to the master clock to itself, is already beginning its work before the last light goes. Mila, in other words, does not wait for full dark. She starts leaning into the door before it opens, and then when the dark is full, she steps through. This is the quiet elegance of a system that was never designed for precision, only for reliability. It does not need to know the exact minute of sunset. It needs only to feel the general direction of the day, its arc, its descent, its closing. The signal is not surgical. It is tidal. It did not evolve to be exact. It evolved to be trustworthy. Let the jaw unclench. Let the space between the eyebrows go smooth. Small places hold the day longest. Trustworthy. That word matters here because the pineal gland is not working alone, and it never has been. Deep inside the brain, just above the roof of the mouth, sits a tiny paired cluster of neurons, the brain's master clock, called the suprachiasmatic nucleus. That name is a mouthful, so think of it simply as the timekeeper. It runs on its own internal rhythm, close to 24 hours, wound tight by the day before and the day before that. And the pineal gland listens to it. Every evening, when the timekeeper decides that night has arrived, it sends a quiet signal down a long chain of nerve fibers out of the brain, around through the neck, back up into the skull, and the pineal gland receives the message and acts on it. Mila begins her shift. The pathway is older than almost anything in the nervous system. It is not elegant as pathways go. It travels a remarkable distance to carry a simple instruction. But it works. It has been working in one form or another for hundreds of millions of years, across fish and birds and mammals, adjusted and refined until the mechanism landing in the human brain was something close to reliable. Here is the thing that surprises people when they first hear it. The suprachiasmatic nucleus, the timekeeper, does not simply react to the light outside. It anticipates. It begins preparing the signal for Mila before the sun has fully set. The internal clock has been watching the arc of the day, noting the slow decline of light in the late afternoon, and it starts the conversation early. By the time true dark arrives, The pineal gland is already primed. Mila is already at her post. This matters because it means the body's evening shift begins in the dimming, not the dark. There is a transition zone, a slow handoff from the daytime systems to the nighttime ones, and it starts while the sky is still a deep amber. The brain does not wait for the last light to disappear. It reads the direction the light is traveling down, and it begins the response. That is a subtle and important distinction. The signal is not just about how much light there is. It is about the change. A steady, dim room does not carry the same information as a room that has been growing steadily dimmer for an hour. The timekeeper reads the trend, not just the moment. Mila knows this. And so the pineal gland, small, tucked in its quiet fold of tissue roughly at the center of the skull, not much larger than a grain of rice when you set it beside a human hand, carries out one of the longest relay routes in the nervous system to deliver a signal that amounts to a single sentence. The day is behind you. What happens next is different. There is a quality to that kind of signal that pure chemistry cannot fully capture. Because Mila's message is not loud. Melatonin does not arrive at the rest of the body like a demand. It arrives like a change in the air, the specific kind of quiet that tells you the afternoon has turned without you noticing. The body reads it not as a command, but as an update. The timekeeper says it is night. The pineal gland confirms it. And then the systems that have been running on daytime settings begin, one by one, to let those settings ease. Core temperature was one of them, as the earlier part of the evening made clear. But temperature is only the beginning of the list. The heart rate settles into a longer, slower rhythm. The digestive system becomes less active, less interested in processing. The muscles soften a degree. None of this is dramatic. None of it announces itself. The body simply stops running so fast, the way a city does after the last commuters have cleared the roads. Mila is not causing any of this directly. That is the thing worth holding. She is the message, not the mechanism. The melatonin that the pineal gland releases does not reach into the muscles and slow them itself. It reaches into the organs that are listening, and they are many, and it tells them what time it is. What they do with that information is their own business. Mila delivers. The body responds. The listening happens through receptors, meaning the specific molecular locks that melatonin fits into, spread across the brain and body. When melatonin arrives at one of these locks, the lock turns. The cell on the other side of the lock changes its behavior. Not because it was forced, because it was told. There is something almost courteous about it. The pineal gland does not override anything. It informs. The system receiving the information decides what to do with it, according to its own logic, its own timing, its own readiness. The whole evening cascade, the long, quiet slide towards sleep, is built on this one act of communication, passed faithfully along a chain of structures that have been doing this together for longer than the species has had a name. And the pineal gland stays at it. Mila's work does not peak and vanish. Melatonin continues rising through the early part of the night, reaches its highest point in the small hours before dawn, and then gradually recedes as the timekeeper begins to sense the first hints of the coming morning. The arc is smooth. No sudden drop, no jarring cutoff. It did not evolve to be a single moment. It evolved to be an entire season of the night. Feel how still the room has become. Warm and quiet and safe. Nothing here needs your attention. Nothing here is asking anything of you at all. There is a reason Mila does not rush. She was never meant to. Think about what melatonin actually is, not what it is sold as, not what the label says, but what it is inside the body. It is a molecule with a message. The message is simple enough to fit on one line. The sun is down, and it is safe to let the day go. That is the whole of it. And a message, by nature, does not force anything. It informs. What the body does with that information is its own business. This is the part people tend to miss. When Mila moves through the bloodstream, and she moves through all of it, not just the brain, but the heart and the lungs and the gut. She is not flipping switches. She is more like a letter carrier who has delivered the same letter to the same address every night for as long as there have been nights. The address is every cell that carries a receptor tuned to her frequency, and there are many of them. Distributed and patient, they wait for her arrival the way you wait for something you know is coming. The body, in this sense, is already half prepared before Mila arrives. That is the part worth sitting with for a moment. By the time melatonin reaches its first receivers in the brain, the suprachiasmatic nucleus, the master clock behind the eyes that first read the dimming light and sent the original signal down to the pineal gland, has already been adjusting the body for some time. Core temperature has been drifting very gradually toward its lower range for the night. The heartbeat has eased a degree. The gut has quieted its daytime pace. All of this before Mila's signal has finished spreading. She is not the first to know. She is the confirmation. Scientists sometimes call this kind of system a cascade, meaning one signal prompts another, which prompts another, like the first domino in a long, unhurried row. Mila is not the whole cascade. She is the moment it becomes official. And here is the part that earns a quiet kind of wonder. The receptors waiting for Mila are not only in the brain, they are in muscle tissue. They are in the immune system. They are in the walls of blood vessels. They are in the reproductive system. They are distributed across nearly every organ system the body maintains. This is not an accident of design. It means that the message melatonin carries, the sun is down, begin to let go, reaches almost everything at once. Not in an instant, But within the span of a quiet evening, the signal has been received broadly, and the body has begun to respond in kind. Mila knows this. The response is not the same in every tissue. Some parts of the body slow their activity in answer to her. Others use her signal as a timing cue for work that only happens when certain thresholds are met, processes that need the cover of low metabolic demand to run at their best. The body is economical that way. It does not do everything at once. It sequences. And melatonin, moving through the system at dusk, is one of the primary signals that starts the sequencing. Think of it as a building at close of business. In the afternoon, every floor is running at full pace. Then, gradually, the lights on one floor go to a lower setting, then another. The cleaning staff, who can only do their work when the offices have emptied, begin to move. The building does not stop existing. It shifts into a different mode, a quieter one, a more inward one. The people who work best in empty rooms begin their hours. Mila is the announcement that the building is changing modes. She does not empty the offices herself. She does not sweep the floors. She does not turn out the lights. She simply makes it known that the time for all of that has come, and the building responds the way any well-run building responds to a reliable signal. It begins to do what it was always going to do once the signal arrived. There is one detail in this that tends to surprise people when they encounter it for the first time. Melatonin does not stay elevated all night. It rises through the early evening, reaches a broad peak somewhere in the deep middle of the night, and then quietly, without announcement, begins to taper. By the time the earliest light is beginning to change the sky, Mila is already stepping back. The signal that was strong at midnight is softening by the small hours of the morning. And by the time true dawn approaches, melatonin has fallen back to its daytime low, and the morning system, the one that is Mila's counterpart in this long daily rhythm, begins to take over again. Mila knows this hour, the hour when she begins to withdraw. She does not resist it. She was never meant to hold the night forever. The season of the night has a beginning and an end, and she honors both. The message she carries is not permanent, it is precisely timed. And its precision, the rise, the broad hold, the slow retreat, is part of what makes it useful at all. It did not evolve to last forever. It evolved to last exactly as long as the night. Notice the weight of your head on the pillow. Heavier than you thought. Let it be that heavy. Here is something that tends to surprise people. Mila does not manufacture herself from scratch. She is built from something that already exists inside the body. Something the body has been making all day long, quietly, without any particular announcement. And the place it comes from is nowhere near the brain. The raw material is serotonin. A small, rounded messenger, warm and unhurried in the way it moves through the body, whose main job during the day has nothing to do with sleep at all. Serotonin is a daytime signal. It moves through the nervous system and helps keep mood steady, attention clear. The general sense that things are manageable. Most people associate it with the brain, but the vast majority of the body's serotonin is made somewhere else entirely. Deep in the gut, among the folds and chambers of the digestive tract, manufactured by cells that line the intestinal wall. The gut produces it. The brain borrows from it. And then, when the light goes down, something remarkable happens. The pineal gland takes that serotonin and converts it. Step by step, through a small chain of chemical reactions, it transforms the daytime messenger into melatonin. The same raw material that was helping the system feel steady at noon becomes, by evening, the signal that the night has arrived. One molecule remade into another. The chemistry is straightforward enough, and the pineal gland has been doing it for a very long time. But the elegance of it, the idea that the day's alertness material becomes the night's permission signal, that part is worth sitting with for a moment. Serotonin, for its part, does not seem to mind. It keeps its head down. It does its daytime work, passes the supply along, and steps back. The pineal gland receives what it needs. Mila has something to work with. The shift can begin. Mila knows this. What the conversion requires, above everything else, is darkness. The pineal gland does not simply transform serotonin into melatonin on a whim. The enzyme that performs the conversion, an enzyme being a small biological tool, a molecular machine built to do one specific job, is itself suppressed by light. Held back, kept waiting. When light reaches the eyes, and that information travels back through the brain's master clock to the pineal gland, the enzyme sits idle. The conversion does not happen. Serotonin remains serotonin. Mila waits in the wings. And then the light goes, the suppression lifts, the enzyme gets to work. The conversion begins, and Mila starts to rise. This is why the timing of darkness matters, in a way that goes a little deeper than simple scheduling. It is not only that the melatonin signal arrives late when light lingers. It is that the entire upstream chemistry shifts. The raw material has been waiting all day. The enzyme has been waiting. The pineal gland has been waiting. When darkness finally arrives, everything moves together, not because anyone is in a rush, but because the system was designed to be waiting for exactly this. A kind of readiness built in. There is something almost courteous about it. The body does not demand sleep, it prepares for it. It has been preparing, in small ways, since the moment serotonin first appeared in the gut that morning. By the time Mila begins her work in earnest, the groundwork has already been laid across a long chain of chemistry that started before the sun was even at its peak. The gut, of course, has no idea any of this is happening. It makes its serotonin, as it always does, attending to its own considerable work. The pineal gland, small and still, receives what it needs through the blood. And the enzyme, that quiet molecular machine, waits for the dark with a patience that is almost architectural, built into its structure, into the way it responds to light signals, into the whole design of the system. Mila knows this hour. What is worth noticing, really worth pausing on, is how far the signal reaches before it even begins. The serotonin made in the gut this morning, the light that entered the eyes this afternoon, the nerve pathway that carried the dimming signal back to the brain's master clock at dusk. All of it feeds into this one conversion. All of it becomes melatonin. All of it becomes Mila, rising slowly through the evening blood. She is not improvised. She is the conclusion of a very long sentence that the body started writing at sunrise. Let that sit for a moment. The morning and the evening are not separate systems running in parallel. They are the same system, moving through time. Serotonin rises with the day. Melatonin rises with the night. One becomes the other. The pineal gland is the hinge. And somewhere in the stillness of the deep brain, in that small pine cone-shaped structure that has been waiting patiently since before the last light faded, Mila continues her work. Not hurrying, not asking for acknowledgement. Simply completing what the day began. The raw material was always there. The darkness was always the key. It did not create the signal from nothing. It simply gave the signal permission to become itself. Warmth is spreading through the shoulders, down the arms, into the hands, slow and even like heat through a room. So Mila has sent her message. It has moved out through the blood, reached the organs, settled into the fluid that bathes the brain. And now something that does not get talked about enough. The message has a shape in time, not just an on and off, a curve. A slow rise, a broad holding period, a taper toward morning. And every part of that curve carries different information. Think of it this way. A letter that arrives all at once tells you one thing. A letter that unfolds in 3 stages. First a greeting, then the news, then a quiet closing tells you something richer. Mila's signal is the second kind. The early part of the rise, the first few hours after dusk, is when the body registers the announcement. The day is done, the mode is shifting. This is when core temperature begins its long, slow descent, not sharply, not suddenly, but like a house cooling after the last window is closed. The muscles loosen their grip on wakefulness. Not because they were told to stop, because the reason to stay ready has quietly been withdrawn. Then the middle of the night arrives. Mila is not shouting by this point. She rarely shouts. She is simply present, holding the signal steady, maintaining the readout that tells the body. Still dark, still night, the schedule holds. This sustained presence is itself information. It is the body's way of knowing how long the night is. Not a clock on a wall, a chemical reading of duration. And here is the part that stops people when they first hear it. The pineal gland signal does not just tell the body that night has come. It tells the body how long the night is. In creatures that live by seasons, and humans are among them, even if modern life has largely obscured this, The duration of the melatonin signal across the dark hours carries seasonal information. A long winter night produces a broad, sustained signal. A short summer night produces a narrower one. The pineal gland, reading the length of the dark, has been whispering about the time of year all along. Mila knows this. In humans, the seasonal signal is quieter than in many other animals. Our lives are built over the top of it now. Artificial schedules, artificial light, the same temperature indoors in January as in July. But the mechanism remains. The pineal gland is still reading the dark. It is still noting the duration. Somewhere beneath the noise of modern life, the old ledger is still being kept. Now consider the taper. As the night moves toward its end, Mila begins to step back. This is not a failure of the signal. It is part of the signal. The gradual withdrawal of melatonin in the hours before dawn is itself a piece of information, a biological first light, an internal announcement that morning is approaching, even before the eyes have registered anything. The body does not wait to be woken up. It begins preparing for wakefulness from the inside, while sleep is still underway. This is where the timing of everything matters most. The taper of Mila's signal and the rise of the body's morning chemistry do not happen in sequence, one finishing before the other begins. They overlap. They are calibrated against each other. The melatonin is stepping back precisely as the cortisol, the body's daytime readiness signal, is beginning its long morning climb. Cortisol Carl, who has been patient in the background through the deep hours, keeping himself at low tide, starts his ascent. Not rudely, not abruptly, but steadily, the way a tide turns, beginning so gradually that the exact moment is hard to name. The overlap is not an accident, it is the design. The body does not want a hard cut between night and morning. It wants a transition. Mila stepping back and Carl stepping forward together make that transition smooth, a handoff rather than a collision. When the handoff goes well, waking up feels like surfacing slowly rather than being lifted out by force. Mila knows this hour, the hour of the handoff, better than any part of her shift. What this means, in the plainest possible terms, is that the melatonin signal is not a single event. It is a sequence: rise, hold, taper. Each phase carries a different piece of information. The body reads all three. And the pineal gland, that quiet structure no larger than a small stone, authors all three from the same basic chemistry, the same converted serotonin, the same ancient enzymes, the same pathway that has been running through vertebrate life for far longer than any of us can comfortably picture. The whole of the night, in other words, is legible to the body because of what the pineal gland writes across it. Not roughly legible, precisely legible. The duration, the season, the approach of morning, all of it encoded in the shape of a single molecule's rise and fall. It did not write a simple instruction. It wrote a full account of the night. Let the breath out slowly. And again. There is no right way to do this. There is only softer and then softer still. There is something quiet and almost extraordinary sitting inside what Mila does every night. She does not just announce that it is dark, she announces how dark and for how long. And that distinction turns out to matter enormously, not just for sleep, but for the deeper rhythms the body runs on across an entire year. Here is the thing most people never consider. The pineal gland is not only a daily clock, it is a seasonal one. Think about that for a moment. The same small structure, no larger than a pea, tucked deep in the center of the brain, is carrying two kinds of information at once. One message is simple. It is night, rest is permitted. The other message is longer, quieter, and far more patient. This is how long the night is right now, and that has been changing gradually for months. The way the pineal gland delivers that second message is through duration, not through any special chemical it adds to melatonin, not through any extra signal it sends, just through time. The melatonin window, the span from rise to taper, stretches in winter when the nights are long and compresses in summer when they are short. The body reads that window the way a reader reads the length of a sentence. A long one tells you something different from a short one, even if the words themselves are the same. Mila knows this, the way something old and practiced knows a thing, not by thinking about it, but by doing it the same way every single season, faithfully, for as long as the species has existed. And the organs downstream have learned to listen. There are tissues in the body that use the length of Mila's nightly message to calibrate processes that have nothing obvious to do with falling asleep. The timing of certain biological rhythms that shift with the seasons. The slow background adjustments that the body makes as the year turns, adjustments so gradual that no single night reveals them, but the accumulated pattern of many nights does. How does this happen without any extra machinery? It happens because the pineal gland is, in essence, an integrator. It takes a continuous stream of information. Light today, dark today, light the day before, dark the day before, and it distills that stream into a simple duration signal night after night. The body does not need to know what month it is. It does not consult a calendar. It reads the length of the dark, and that length is the calendar. This is, when you sit with it, a remarkable piece of engineering. The body solves the problem of knowing where it is in the year without a single external reference beyond the light that comes through the eyes each morning and the absence of that light each evening. Two inputs, one output, duration, and from that duration, an entire seasonal awareness. Mila does not manufacture anything different in December than she does in June. The molecule is the same molecule. The receptors that receive her message are the same receptors. What changes is only the length of time she is present. And the body, it turns out, is exquisitely sensitive to that difference. Long window or short window, it knows. It has always known. There is an old way of thinking about hormones that imagines them as simple on-off switches. The switch flips, the thing happens, the switch flips back. Melatonin does not fit that model. It never did. It is less like a switch and more like the hour hand of a clock, meaningful not just in its position, but in how long it has been moving in one direction. The information is in the duration as much as in the presence. Cortisol Carl, for his part, reads the opposite end of that signal. When Mila's window is long, Carl's own morning rise arrives later relative to the light. When the nights shorten toward summer, the handoff comes sooner. They are counterweights, moving through the year together in a slow and mostly unconscious dance. Carl does not choose this. He is as subject to the seasonal rhythm as anyone. He adjusts when Mila adjusts, and they maintain the proportion between them that the body has come to expect. And all of this, the daily signal, the seasonal encoding, the downstream calibration, happens without any effort from the person lying in the dark. The pineal gland does not need to be reminded. It does not need to be coaxed. It needs only what it has always needed, the simple, reliable presence of real darkness falling at a consistent time. Give it that, and the rest of the system follows. Not because anyone told it to. Because it has been following the same instruction for longer than memory reaches. The instruction written in the length of the dark itself. The melatonin signal, it turns out, is not just a nightly note passed to the body before sleep. It is an ongoing record of where the year stands, not a simple announcement. A long, careful log. Nothing is required of you now. Not thinking, not planning, not remembering. All of it can wait until morning. Not a simple announcement. A long, careful log. And here is something that tends to stop people when they first hear it. Melatonin is not a human invention. It is not even a mammalian one. This same molecule, made in the same basic way, released in the same basic rhythm, has been found in creatures so ancient that the word ancient barely covers it. Single-celled algae, certain invertebrates. Fish that have not changed much in hundreds of millions of years. The molecule preceded the brain that now produces it. The pineal gland, in a sense, is the brain catching up to something that chemistry figured out long before neurons existed. Mila, then, is not a recent hire. She belongs to one of the longest-running operations in the history of life. What that tells us is worth sitting with for a moment. When a system is that old, when the same signal, the same rhythm, the same chemical architecture appears across creatures separated by vast stretches of evolutionary time, it suggests that whatever the signal does, it matters enough that life kept it. Evolution is not sentimental. It does not preserve things out of habit. If melatonin is still here, still functioning in almost exactly the same way in an alga and in a sleeping human, then the information it carries must be genuinely useful. The information, as best we can tell, is this: the ratio of light to dark, the turning of the planet, the position of the sun, read not by the eye exactly, but by the absence of it. That is what Mila encodes, not a feeling, not a command, a position in time. A place on the wheel. Now, here is the part that often surprises people. The pineal gland in early vertebrates, fish, amphibians, certain reptiles, sits close enough to the surface of the skull that it can detect light directly through the tissue. In some lizards, there is even a structure called the parietal eye, a small photosensitive patch on top of the head, connected to the pineal region that reads ambient light more or less on its own terms. The pineal gland, in those animals, is genuinely light-sensitive. It sees for itself. In mammals, that direct pathway closed off, the skull thickened. The brain grew around the gland, tucking it deeper and deeper into the center of things. The pineal gland lost its own window. And so it had to rely on a relay, the suprachiasmatic nucleus, the master clock, reading signals from specialized cells in the retina and passing the information inward along a chain of nerve signals. Mila's ancestors could look at the sky. Mila cannot. She works entirely from second-hand information. And yet the result is the same. The rhythm holds. The signal rises in the dark, falls at dawn, encodes the season, communicates the night. The architecture changed. The function did not. There is something quietly remarkable in that. The body found more than one way to keep the same conversation going. When one pathway closed, another opened. When direct light detection became impossible, an indirect pathway assembled itself, one that is, if anything, more sophisticated. Because the suprachiasmatic nucleus does not just pass light information straight through. It integrates it. It smooths it. It anticipates. It has been watching the trend of the light for hours before it sends the signal that tells the pineal gland to begin. Mila does not just receive a fact. She receives a considered opinion. And this ancient lineage of the molecule has one more implication worth mentioning, quietly, before the thought settles. Because melatonin appears so early in the history of life, before nervous systems, before brains, before the elaborate signaling networks that now carry it, researchers believe it may have originally served a different purpose entirely. Something closer to an antioxidant, a molecule that scavenged reactive compounds in cells, protecting them from the kind of chemical wear that light and metabolism can cause. The timekeeping function may have come later. Or the two functions may have always been intertwined, because the rhythms of light and dark are also the rhythms of metabolic stress, and a molecule that rose at night to protect cells from the day's accumulated wear would naturally become entangled with the question of when the night was. Mila knows this dark in a way that runs deeper than any single body. She is carrying a memory that predates memory. What this means for the sleeping body is not dramatic. It does not change the texture of the night or the quality of the dark, but it does change what it feels like to understand the signal. When Mila begins her work at dusk, rising gradually, informing the system that the light has gone, she is not doing something new. She is doing something ancient. Something tested across so many generations, in so many different forms of life, in so many different environments, that the question of whether it works has long since been settled. The only real variable for any individual animal in any individual night is whether the dark actually comes. Whether the signal that has been reliable for hundreds of millions of years is allowed to run its course without interruption. When it is, the body sequences its night the way it always has. One system easing into the next. The chemistry slow and orderly and old. Mila carries that history. Every rise, every hold, every gradual taper before dawn, it is all part of the same unbroken line. It did not make the night simpler, it made it trustworthy. Notice how easy the breath has become. Coming and going. Coming and going. You are not managing it. It knows the way on its own. Here is something the body does every single evening, so quietly that most people never notice it is happening at all. The temperature drops. Not the room temperature, though that matters too, in its own way. The body's own core temperature, held steady all day at a precise and careful level, begins to drift downward as the evening deepens. A degree or so, not a dramatic fall. More like a slow exhale the whole body takes, one that has been building since mid-afternoon without announcing itself. This is not an accident. It is part of the same signal Mila is already sending. The connection between melatonin and temperature runs through the body's blood vessels, specifically the vessels near the skin. As Mila's signal spreads through the evening hours, something happens in those outer layers. The vessels there widen slightly, in a process the body uses to release heat outward. Not conserve it, release it. The core cools because the surface is gently opening its doors and letting the warmth out. This process has a plain name: heat dissipation. The technical term is peripheral vasodilation, meaning the widening of blood vessels near the skin's surface. But the plain version is enough. The body is venting warmth the way a house vents heat through open windows in the evening, deliberately, gradually, without drama. And the lower core temperature that follows is one of the genuine preparations for deep sleep. The brain and body do their deepest repair, work at a slightly cooler internal setting. The drop is not a side effect of something else happening. It is part of the plan. Mila knows this. She has known it for a very long time. The timing between melatonin's rise and the body's temperature curve is not coincidence. The two run together the way a conductor's hand and the first note of a phrase run together. One leads, the other follows, and they have rehearsed this enough that the interval between them is always the same. The hands and feet are worth a small mention here. Anyone who has ever noticed their hands growing warm in the evening, that faint flush in the palms before sleep, the feet that feel less cold than expected under the covers, has felt this mechanism directly. The warmth at the surface is the warmth leaving the core. It moves outward through the widened vessels and dissipates at the skin. The core cools, the surface warms, and the body settles, not dramatically. Never dramatically. This is not a system that makes announcements. What is worth sitting with is the elegance of the sequence. Mila's signal, which is itself downstream of darkness and upstream of the brain's response to night, carries within it not just a timestamp, but a physical preparation. The message is not only the day is over. It is, and here is what we are going to do about it. The lowering of core temperature is one of those preparations. It is the body adjusting the thermostat before the work begins. The way a good workshop is kept at a certain temperature, not for comfort, but for the materials being worked with. Deep in the brain, the pineal gland does not reach down and touch a temperature dial. It does not need to. The signal it releases carries enough information that the body's own vascular system handles the adjustment without further instruction. One signal, many responses. Mila is not a manager who micromanages. She is a message that trusts its recipients. There is something else here, quieter still. The temperature drop in the evening is one of the most reliable markers researchers use to track circadian timing, the body's internal daily schedule. Not because temperature is dramatic, but because it is consistent. It follows the melatonin signal with such regularity that the two curves, melatonin rising and core temperature falling, have become a kind of paired signature of a well-timed evening. When one shifts, the other tends to follow. This is why light matters so much to the temperature rhythm, as well as the melatonin rhythm. When light delays Mila, when the signal from the pineal gland arrives later than the body's internal clock expected, the temperature curve tends to shift with it. The whole sequence slides. Not broken, the body is remarkably patient about preserving the shape of the rhythm, even when the timing drifts. But slid. The pineal gland, sitting quietly in the center of the brain, holds all of this together. It is the point where the light information from the eyes becomes a chemical signal, and that chemical signal becomes a vascular instruction, and that instruction becomes a physical change in the temperature of the body's core. A chain of conversions, each one faithful to the one before it. And all of it begins with darkness, real darkness. The kind the pineal gland has been waiting for since the afternoon's angle of light first began to change. Mila knows this hour. She knows the sequence by heart, the widening vessels, the warmth moving outward, the gentle fall in the core. She has run through it more times than memory could contain. And she runs through it the same way every time, because the body does not need variety here. It needs reliability. The cooling is not a sign that sleep is arriving. It is part of how sleep arrives. It did not make the process feel intentional. It made it unmistakably so. There is nowhere else you need to be. Nothing you have forgotten. The night is long, and it belongs to you. There is a question worth turning over quietly here in the dark. The body has no calendar on the wall. It has no phone telling it the date, no watch on its wrist, no window to glance through. And yet, somewhere deep in the architecture of the night, It knows roughly where it is in time. Not just the hour, the season, the approximate position of this particular day inside the whole long wheel of the year. How does it know that? Mila knows this. Here is the mechanism set out plainly. The pineal gland does not count days. It does not store memories of previous nights. What it does, what it has always done, is measure duration. Each night, the melatonin signal rises, and then, after its long, quiet hold, begins to taper before dawn. The length of that window is not fixed. It stretches and contracts across the year in precise step with the actual length of the night outside. A long winter night produces a long melatonin window. A short summer night produces a short one. That difference is the calendar, not written anywhere, not stored as a number, just encoded in the width of the signal itself, the way a shadow encodes the angle of the sun without needing to know geometry. The body reads the duration of Mila's presence the way a patient reader reads a long sentence. The length is part of the meaning. Turn that over for a moment. The pineal gland is not simply telling the body it is night. It is telling the body what kind of night this is. A short one close to the summer solstice, when the light returns quickly, or a long one deep in winter when the dark holds on. And all that information is carried not in the chemistry of the molecule itself. Melatonin is melatonin, the same signal it has always been, but in the timing. In how long the signal persists. Duration is the data. This is the part that tends to produce a quiet moment of recognition in anyone who hears it explained. The body has been keeping a rough seasonal calendar its entire life, and it never required a number to do it. The pineal gland simply measured the dark, and the dark told it everything. Now, and this is where the thing deepens, that seasonal information does not stay in the brain. Mila's signal disperses widely, as it always does, binding to receptors throughout the body. And some of those receptors are connected to systems that respond differently to a long melatonin window than to a short one. Systems involved in metabolism, in immune readiness, in the body's broad internal sense of what resources to hold and what to release. The body, in a very real sense, adjusts its posture slowly, over weeks and months, in response to the accumulated length of the nightly melatonin signal. It is not a dramatic shift. It is a slow, continuous calibration, like a ship making a 1-degree adjustment to its heading, day after day, season after season. None of this requires the body to be consciously aware of any of it. That is the elegant part. The pineal gland reads the dark. It releases Mila. Mila carries the duration of the dark as part of her signal. The receiving systems downstream interpret that duration. And the result is a body that is very quietly oriented in time, not just to the hour, but to the season, without ever having checked a calendar. Cortisol Carl, whose morning rhythm has been doing its slow nightly retreat through these hours, is part of this downstream system too. His seasonal rhythm is partly shaped by the length of Mila's window, though neither of them would put it that way. They are both reading the same underlying information and responding in their own register. Mila sets the duration. Carl adjusts his waking amplitude accordingly, nudging slightly higher or lower across the year in a pattern that follows the light. They do not coordinate. They simply both respond to the same signal, the way two musicians in a large ensemble can stay in tempo without looking at each other, because they are both listening to the same beat. And here, quietly, is the part that tends to settle something in the mind at this hour. The body has never needed to be told what month it is. It has never needed a clock. What it needs is the dark, uninterrupted, genuine, early enough dark, so that Mila's window can be the right length, so that the signal encodes the season accurately, so that the body's slow, seasonal orientation continues undisturbed. The pineal gland has been performing this calibration for longer than human record keeping has existed. Longer than calendars, longer than agriculture, longer than fire used for light. The melatonin window was encoding seasonal information in vertebrate bodies before any creature on this planet had a concept of a year. The year was already in the signal. It had always been. The breath is slower now. The weight of the limbs settles a little further into whatever is beneath them. The body does not need to understand any of this consciously. It is already doing it. Has been doing it all night, quietly and without announcement, the way a very old and very reliable process tends to work. It did not make the dark feel smaller. It made it sufficient. The night is deep now. Deep and still and very comfortable. There is nothing to do here, nothing to solve. You just need to be present in this quiet, in this dark. And so the dark held its shape. Not dramatically, not with any announcement. It simply continued being what it was, the absence of light. And the pineal gland continued doing what it does, which is to read that absence and keep the count. Here is something that takes a moment to appreciate. Mila's signal does not stay in the brain. It does not hover around the pineal gland like a local weather system, affecting only the neighborhood. It moves. It disperses into the blood, into the cerebrospinal fluid, the slow, clear current that bathes the brain and spinal cord. And from there, it reaches places that seem, at first glance, to have very little to do with sleep at all. The gut, for instance. The gut has melatonin receptors, so does the immune tissue. So do certain cells involved in how the body handles the sugars and fats that arrived with the day's meals. Not one system. Many, and each of them is listening for the same quiet signal. Night has come. Adjust accordingly. What the adjusting looks like varies by location. In some tissues, it means slowing down. In others, it means shifting from one kind of work to another, maintenance rather than production, repair rather than response. The body, in other words, is not a single room that goes dark all at once. It is many rooms, and Mila moves through them one by one, leaving a small note in each doorway. Mila knows this. She is not in a hurry. She was never designed for urgency. The signal spreads at the pace of the blood, which is to say it arrives in good time, without drama and without fanfare. By the time the body is well into the night, the message has reached nearly everywhere it needs to go. Now here is the part that tends to surprise people. Melatonin does not tell these distant tissues what to do in any precise and specific way. It is not an instruction manual. It is closer to a shift change notice posted on a bulletin board, brief, reliable, always there at the same hour, and trusted precisely because it is never early and almost never late. The tissues that read it have their own internal knowledge of what to do when night comes. Mila's signal is not the knowledge. It is the confirmation that the moment has arrived to act on it. This is a distinction worth sitting with. The body already knows how to sleep. It already knows how to run its nighttime processes, the cellular tidying, the tissue maintenance, the slow rhythms of recovery that accumulate through the dark hours. What it needs is timing. What it needs is the reliable arrival of a signal that says, yes, now, this is the moment. The pineal gland provides exactly that. Nothing more and nothing less. There is a kind of organizational elegance in this that is easy to miss. A system that told every organ what to do, in detail, every night would be fragile. One confused message and the whole chain breaks. But a system built around a single timed signal, one that each tissue interprets according to its own built-in program, is remarkably robust. The pineal gland does not need to know what the gut is doing with its melatonin receptors. It only needs to send the signal on time. The gut handles the rest. This is why the timing of the signal matters so much more than its volume. Mila does not need to be loud. She needs to be punctual. A strong melatonin signal that arrives late is still late. And a body expecting a signal at a certain hour will wait for it, not consciously, not impatiently, but in the way that a room waits for a key that has not yet turned in the lock. Mila knows this hour. She has always known it. The schedule was not something she learned. It was something she arrived with, built into the enzyme that makes her, the receptors that receive her, the cells that act on her arrival. The whole system was calibrated together over a very long time, and it runs without any deliberate effort from the body that carries it, which is perhaps the most reassuring thing about it. The body does not have to remember to begin the night. It does not have to decide. The pineal gland in the dark begins the sequence. Mila moves outward. And the many rooms of the body, each in their own way, receive the notice and begin to do what they were always going to do when the right moment came. There is a word for a system like this: distributed but coordinated, autonomous but synchronized. Scientists sometimes reach for terms from music, The body's organs are said to be entrained to the same rhythm. The way instruments in an ensemble find a shared tempo without being conducted note by note. They follow the same underlying beat. The pineal gland keeps the beat. Mila carries it outward. The body does not sleep because it is commanded to. It sleeps because many systems, receiving the same quiet signal, each arrive at the same quiet conclusion. It did not make the process simpler, it made it whole. You are further from waking now than you were a few minutes ago. That is the whole direction of travel. Just down and quieter. And now the night is very deep. The pineal gland holds its signal steady, not rising any further, not yet falling. Just present, the way a lamp left on in a quiet room is present, not noticed, not needed, simply there, doing exactly what it was made to do. Mila knows this hour. She has been working for a long time now. Since the light first faded, since the eyes sent their slow message inward and the brain's old timekeeper received it. All of that happened in its own order, in its own time, exactly as it was meant to. The signal went out. It reached the body's edges. It moved through blood and through the quiet fluid of the brain. Every tissue that needed to hear it has heard it by now. The body is cooler than it was at dusk. Just a little, enough. The warmth drifted outward through the skin, the way heat leaves a stone after the sun goes down. That drift is the signal made visible, or rather, made feelable in the weight of the limbs, in the ease of the breath. Let the breath be easy now. There is nothing to carry in this part of the night. The work is done, not finished exactly. It will continue quietly through the hours still ahead. But the announcing is over. The permission has been given. What comes next does not need to be watched. Mila does not watch it either. She simply holds the signal. That is the whole of her work in this deep part of the night. Not doing something new, but being what she is, steadily, so that everything downstream can continue being what it is. The pineal gland, that small and patient structure, sits at the center of it all. No larger than a pea, unremarkable to look at if you could look at it. And yet here, in this hour, it is the still point that everything else is organized around. Not commanding, not forcing, just marking the time, the way a lighthouse marks the shore, not moving the ships, only telling them where the ground is. The ground is here. The night is here, the body knows. Somewhere upstream, serotonin did its part. It belonged to the day made in the light, carried through the hours, useful in its own quiet way. And then, when darkness came and the right conditions gathered in the pineal gland, it gave itself over. It became the material Mila needed. It became the signal. The day becoming the night. The light becoming the dark. It all continues into itself, each thing handing off to the next, each part trusting that the next part will be ready. And it always is. The signal is still rising and falling with the season, though you would never know it from the inside. The duration of this night is being recorded, as it always is, longer than summer, shorter than the depths of winter. The body is orienting itself in the year, without a calendar, without a thought, without any help at all. Mila knows this. The ancient part of this is worth sitting with, even now, even as sleep deepens. This molecule, this signal, older than memory, older than any nervous system complex enough to have a memory, doing what it has always done. Moving through the dark, marking the time. Telling the living thing. Rest, the world is still, the night is long. This is what the dark is for. The breath is slower now. The limbs are heavy in the easy way, not burdened, just settled, the way furniture settles in a house that has grown quiet. The pillow is familiar, the dark is full. Nothing is asking for anything. Not the pineal gland, not the signal moving through the blood. Not Mila, who is doing what she does, holding the line steady, without effort, without urgency. This is the deep part of the night, and it belongs to no one. It simply is, wide and dark and very still. Let the shoulders drop the rest of the way. Let the jaw unclench if it had not already. Let the mind go wherever the mind goes when there is nothing left it needs to do. The signal is held. The body is held. The night goes on, doing its slow and necessary work, and none of it requires watching. Sleep is not something that has to be found. It was already here, waiting just past the door that Mila opened at dusk. The door is open still. You are drifting now, slowly and gently, the way a small boat drifts from the shore. No hurry, no direction to hold. The door is open still. And the pineal gland rests in the dark behind it, small and still, no bigger than a pea. Sitting at the very center of the brain, equidistant from everything, like a single lamp left burning in a quiet house. Mila's signal is still moving. Through the blood, through the fluid. Slow and even, The way a tide moves when the wind is gone and the water has nothing left to argue with. She has been at work for hours now. She is not tired. This is simply what she does. The body understood the message a long time ago. Every organ that needed to ease did. Every system that needed to quiet found its lower setting. The message was not complicated. It was never meant to be. The day is over. Rest is allowed. That was always the whole of it. Mila knows this. And so the night holds. Deep now, the kind of deep that has weight to it. The kind of dark the pineal gland has always been waiting for. This dark specifically, not approximated, not suggested. Real. Somewhere earlier in the evening, before any of this, there was serotonin. Made mostly in the gut, of all places. A daytime messenger going about its daylight work. It had no idea it would end up here. But the pineal gland knew. When darkness fell and the conversion enzyme woke, it took what the day had built and made something new from it. That is what happened. That is what always happens. The same quiet chemistry, every night. Nothing invented, nothing borrowed, only the day handing itself over to the night through that one small step. In that one small gland, in the center of everything. And the signal has a shape, a slow rise at dusk, a long-held middle, a gradual easing before first light. Not a spike, not a flash. A shape that takes hours to draw itself, the way a season takes months. The pineal gland is patient that way. It has been doing this longer than patience has a name. Longer, in fact, than most things you might name. The molecule Mila carries is one of the oldest signals in the living world. Older than skulls, older than sleep as we would recognize it. It was here in forms of life, so simple they had no brain to speak of, and it was doing something even then. Something about timing. Something about the dark and what to do inside it. That is the part that settles a person if they let it. This is not new. None of this is new. The body you are resting in right now is running a program written over an almost unimaginable stretch of time. The pineal gland did not invent this evening. It simply kept the appointment. Mila knows this dark. And the warmth that left the skin a few hours ago, that quiet release of heat from the blood vessels near the surface, the body cooling itself from the inside out, that is still holding too. Core temperature is down. The body is in its preferred condition for the deepest kind of rest, not cold. Just right. The way the night is just right when the light is truly gone. Everything is doing what it was always going to do. The pineal gland sent the signal. The signal reached its destinations. The body received it and began its long, coordinated settling. No instruction manual. No override switch. Only timing kept faithfully in the dark. Somewhere much later, before morning, the signal will begin its slow taper. The night is not there yet. The melatonin window is still open. The seasonal encoding embedded in its duration, longer than a summer night or shorter, depending on the time of year, is still being read quietly by the body's tissues in ways no waking thought is required to follow. The pineal gland is not watching the clock. It is the clock, and the clock is calm. Let the shoulders be heavy. Let the breath find its own pace. The small gland at the center of the brain is keeping the time. Mila's signal is still held, still even, still moving through the quiet systems of a body that has finally let the day go. That is enough. That is, in fact, all it was ever meant to be. More than enough. Let your shoulders drop a little further. Let the back of your neck soften. The pillow is doing the work now, not you. That is, in fact, all it was ever meant to be. More than enough. And now the night has done its work. The pineal gland sits where it has always sat, small, still, deep in the center of everything. It asked no credit. It made no announcement beyond the one it was built to make. Darkness arrived. Mila went to work. The signal moved outward through blood and through the quiet fluid of the brain, reaching every corner of the body with the same unhurried message it has carried since long before there were bodies like this one to carry it to. The day is over. Sleep is allowed. Mila knows this hour. Somewhere upstream, the serotonin that began the day as something else entirely, a daytime signal built mostly in the gut, busy with the work of waking hours, was handed forward, quietly converted, transformed inside the pineal gland into the molecule the night required. Nothing wasted, nothing invented from nothing. The chemistry of the day folding into the chemistry of the night, the way one long sentence becomes the next. The melatonin signal is still present, not rising now, not tapering yet. Just held broad and steady, the way a long note is held in music when the song is settling toward its end. The body reads this as duration, as season, as the simple, wordless confirmation that the night is long and the sleep can be full. Each organ received the message and did with it what it was always prepared to do. The gut slowed. The immune tissue turned quietly inward. The blood vessels near the skin stayed easy and open, letting the warmth the body no longer needed move outward, away, leaving the core cool and still and ready for the deep work that only comes at depth. And somewhere farther off, not yet, but coming, the first small preparations for morning are beginning without urgency. A slow gathering, a long way off, nothing to attend to now. Mila knows this. The pineal gland does not sleep exactly, but it rests in its own way. The signal it carries is self-sustaining through the dark. It needs no further instruction. The clock was set long before the eyes closed, and it will run until the light returns to reset it. This is the oldest reliability in the body, older than language, older than memory. A rhythm so deep it does not need to be remembered because it was never forgotten. While you sleep, Melatonin Mila is already at work. The pineal gland is holding its steady melatonin signal through the dark, keeping the body's sense of night intact, encoding the length of this particular darkness, so that every system downstream knows not just that it is night, but how far through the night the body has come. The core temperature rests at its lowest point. The whole long chemistry of the evening is exactly where it was always meant to arrive. You don't have to do anything. Your body knows exactly what to do. It's been doing this work for your entire life, every single night, so let it, trust it. And as you drift deeper now, Melatonin Mila will be here when you wake up. Quieter, calmer, better, sleep well.